Hello, good morning or afternoon or evening, depending where you are. Thanks for joining our webinar today. If you have any questions during the session, please submit them via the Q&A button at the top of the interface. Please submit them via the Q&A button only, and those questions will be answered at the end. This webinar will be recorded and you will receive a copy of it delivered to your email account after the webinar. I hope you enjoy, and I'll now hand you over to our experts, Sami Guizani, who's the Product Marketing Manager at ST Microelectronics, and Johan Lopez, who's a Senior Pre-Sales Engineer at the Cube Company. Over to you guys.
Thank you very much. Hello, everyone. I'm Sami Guizani, Product Marketing at ST Microelectronics, responsible for graphic solutions. And I will start presenting to you quick, facts about STM32 graphic MCUs, and then hand it over to Johan for a live demo for this webinar. So first, this is what we are trying to do on STM32 with graphics. So we are trying to accelerate what we call the HMI of things. We are seeing all embedded products getting smarter, offering more capabilities and more features. And so it is clear that these products are needing better user interface so that users can benefit from all these new features. The way we are doing it in STM32 products is trying to enable this in really cost-effective product, MCU-like products. And so we are adding some smart hardware acceleration, especially our ST Chromart, that is accelerating the 2D copy, the transparency effects, pixel format conversion, and also is helping to efficiently manage the fonts, yes. And so with this kind of acceleration, you can now have a fluid graphic UI with only 4% of the CPU that is used, while before it was needed more than 80% of the CPU. Other smart IPs we are embedding in our products is the Chrome GRC, and so this is a memory optimization IP that is more for the round displays, where we enable saving of 20% of the total RAM when using a round display, and so we are not dealing with the non-useful pixel. A final acceleration, which is JPEG hardware accelerator, allowing you to add to your graphic UI videos that are used most of the time for startup or for tutorials. And so in small and cost-effective MCUs, you can now add this kind of tutorial videos or startup videos. Our products are supporting a large range of display interfaces, so from classical parallel interfaces to TFT, but also to advanced MIPI DSI kind of products. And our offer today is coming with more than 200 advanced part numbers for graphics, supporting the different accelerations, and also available in different package formats, and so convenient for different needs in industrial and consumer markets. Today, we have more than 10 million units of graphic products, STM32 advanced graphic MCUs in production in the market today. Our new additions are F7 and H7 value lines, which are new low-cost options, let's say, where the flash is kept to the essential so that you can still have boot flash. And these products are, of course, containing all our accelerations, so Chromart, JPEG, and also coming with large choice of packages. And then recently, we are now sampling a new product called the STM32 H7A, which is coming with big SRAM, allowing to handle up to half VGA resolution without any external RAM, and in packages as small as QFP 64 pins. So this was a quick view on STM32 offer. I hand it over now to you, Johan, for all the cute presentation and the live demo.
Thank you, Sami. Good morning, everyone. I will start sharing my screen. All right, so yes, I will now take you through the steps to get Qt running on one of ST's board. But actually, before I start with this, I would like maybe to make a small introduction to Qt because I'm not sure if everyone here in the webinar actually knows about Qt and what it is. So Qt is essentially a cross-platform application development toolkit. It's native, so it means you use C++ to develop with it. But not only, you also have a QML language to declare user interface with. And you get also tools for development, so a full integrated development environment called Qt Creator, as well as design tools called Qt Design Studio and Qt 3D Studio to bridge the gap between developers and designers. And as I said, it is fully cross-platform, so you just write your code once, and then you can just simply recompile to target basically most of the operating system on the market today, be it for embedded with embedded Linux or Windows embedded, or some selection of the most common RTOS like QNX, VxWorks, or Integrity. You can also target desktop with the same code, so Windows, Linux, or Mac, and also the main mobile platforms like Android or iOS. And since recently, we also released a whole new feature in Qt to also target the web with what we call Qt for WebAssembly, where you can simply recompile again the same app as you would make for another platform, and then it can be run inside a modern web browser. But another of the new feature, and we have released that just last week, is Qt for MCU, which is what we're going to talk about today. Essentially, it lets you use one of the core technologies inside Qt, which is called Qt Quick, also known as QML. And that is the main technology to design graphical user interfaces in Qt. And we took that to be optimized for microcontrollers. And as you can see on the image on screen right now, it's actually a bit different compared to how Qt works on all the other platforms I showed you, simply because MCUs are much more resource constrained, and we cannot run all the regular Qt libraries on it if we want to really optimize, especially the size. So while on the typical, let's say, higher-end embedded platform, you would have Qt Quick sitting on top of the regular Qt libraries, which you would use for everything, not just the GUI, but potentially for many other things. And then under it, you would have always an operating system. In the case of what we're going to talk today, Qt for MCU, you still have access to Qt Quick in the QML language, but just under it, there's now a new runtime engine called Qt Quick Ultralight, which only takes care of rendering a QML UI. And in that case, you do not have access to all the other Qt libraries. So any, let's say, business logic, network access, and so on, you would have to use other third-party libraries. And what that means is that now, with this new runtime, you do not need an OS anymore. That means you can run bare metal. And also, it's much lighter, really. So as low as it can get for this kind of lower-end hardware. So as I said earlier, today we're going to go through the different steps to get you up and running with Qt for MCU on one of ST's board, namely the STM32 F769i Discovery. And I will actually, through this presentation, share a video feed of a camera I have here to show you the actual board and what I will be deploying to. So right now, what you can see is it's the standard example that we provide with the package. You might have seen this already, or you might even have tried it all yourself, because we have provided the binaries already now for a couple of weeks. And this is also included in the evaluation package. It runs pretty well at 60 FPS. It only uses a few hundreds kilobytes of memory. And also just to mention, this evaluation package can also run on the STM32 F7508. But again, today we'll be using the first one. So before we actually start making a small, simple project, I want to remind, let's say, all the software requirements, all the things that you need to install on your PC to be able to use the evaluation package. First of all, you will need Windows, at least for this evaluation package. We only provide what's needed for this platform. Later, there will be also Linux supported. But as of now, you will need Windows. You will, of course, need the Qt for MCU evaluation package as well. I will show you in a bit how you can get that if you haven't got it already. Optionally, you can get also Qt Creator, our development environment. I'm saying optional because you could also just use command line tools or other tools, but all the steps I will show you today will be using Qt Creator. You will also need CMake, at least version 3.13. That's because Qt Ultralight is based on the CMake build system, not on QMake, our own build system. So this is just mandatory. You will also need Clang. If you actually using Qt Creator, you do not need to download it separately because it's included with Qt Creator. And finally, on this list of tools, you will also need Python 2.7 32-bit. And then when it comes to actually compiling for the SD board, you will of course need an ARM toolchain. The latest one is known to work, but some older ones should work as well. And a list of ST tools. So the STM32 Cube F7, that's the SDK for the F7 series of board. The ST-Link utility, that's for flashing to the board. And then finally the Cube IDE and the Cube Programmer. So this, you won't actually need to use it directly. This is only needed to be able to debug from Qt Creator. Let me show you now just quickly how you can get the Qt for MCU evaluation package. If you go on the Qt account on our website, and if you already have a Qt for device creation license, any kind, it can be an actual license, but also if you have access to an evaluation license of Qt for device creation, then you can get here in the download section, and in this menu here, and you select, you will automatically add this line here, Qt for device creation MCU evaluation. Just select that. Click on the link here and click download, and you will get everything needed. If you do not have a Qt for device creation license, then if it's really just for trying, you can request from our website an evaluation license for Qt for device creation, and then you will get access to this page to download the package. So once you have downloaded it, it's just a zip file. You just extract that anywhere, it doesn't matter. And before we even get started, there's one thing that needs to be done for everything to work correctly. And that is to set a couple of environment variables. And if you have a look here, the environment variables, you just need to add to the path environment variable these two lines here. So basically you need to add the bin directory of Qt Creator into the path, as well as the Clang. As I said, Clang is included with Qt Creator, so just add also the Clang bin directory from Qt Creator inside the path. This is necessary to get all the tools basically to work correctly with Qt Creator. And once you have done that, then you can actually start Qt Creator, which is here. And before creating a new project, I will actually show you the content of the package so you have an idea a bit of what's inside. Don't look for, I'm trying to understand what it is. So this is the content of the package. It has just a bin directory with just the tools you will need to compile a Qt for MCU application. In the CMake directory, you have all the configuration file for building. In here, in the demo image, these are pre-compiled demo images for the ST board. This is basically what you're seeing here on the camera. So you have that, and you can just flash it directly to try it. These demos are also included in the example here, so you have access to the source code of this example. That's this one, the thermal example, but you also have access to a couple of other examples. And then you have the doc in HTML format, which of course I recommend you to read. All the steps that I'm going to describe today are also documented inside this documentation. And well, basically just the include directory, the lib, and then these are just a bunch of fonts being used by the examples. So let's create a small project for the STM F7 board. But before we even do that, there are actually a few steps to configure Kit Creator to be able to build for MCU. And the reason is that eventually this will be all very straightforward. We will make it as seamless as possible as any other platform we support, while you will just create a project, build and run, and there will be nothing to really configure manually. But since this is the initial evaluation package, it doesn't include yet the full Qt Creator integration. So that's why there are a few things to configure manually. And the first one is to enable a plugin, which is not enabled by default. So to do that, you can click on the Help menu here in Qt Creator, and then you see that you have an About Plugins entry. Just click on that. And then you have the full list of all the Qt Creator plugins, and you have a filter field here at the top. In this one, just type in bare or bare metal, but bare should be enough. And you see there is bare metal experimental plugin at this point, and just enable it by clicking the checkbox here. Close the window, and to actually take effect, you need to close Qt Creator and restart it again. So now the plugin is enabled. And the next thing to configure is to add a kit. A kit in Qt Creator is simply a configuration to be able to compile a program for a specific target. So in this case, we need to configure a kit to compile for the STM board. So for this, we click on the tools menu here. We go into the options, and here you see that we have the kit section here. And a kit, if we look at any of these kits I already have here for compiling for desktop, you see that it's a combination of a device, a compiler, a debugger, and so on. So before we even create a kit, we have actually to configure a few of these needed things, like for example, the debugger. So for that, we first need to add the debugger. We're still in the same section. We go to the debugger tab here, and we will add the ARM debugger. So click on the Add button here. Just name it. So I will just call it ARM GDB. Then on the field below, just click on Browse, and you need to go and find where you have installed the ARM toolchain. In my case, I just installed it at the root of my C drive in this directory here, and go in the bin directory. And you need to select GDB, but not the regular one. You need actually to select this one, the one which ends with -py. And that's basically another version which accepts Python scripts to control the debugger. And that's the one you need to select. So here we have added our debugger. Just click Apply. And then the last step for the debugger is actually to configure it for correct initialization. For this, we need to go inside the device section here, then into the bare metal tab. Then you click on Add Default. You can just name it. It's really just a profile, so let's call it ST-Link GDB. We can leave this with the default value. Here we just gonna change the port used by the debugger. Let's put 61234, and there are a couple of comments we need to set here. In the init comment section, we need to set just load. And in the reset commands, we need to set mon reset. Once you have done that, just click apply. And we're done with the debugger. The last step before we actually create the kit is to configure a device. So the device we will actually be deploying to. So for this, I go into here, the device category, and I click on add a new device. It needs to be a bare metal device here. Just start the wizard. You can call it whatever you'd like, and I will just call it STM32 F769i. And select here in the GDP server provider the profile we just created. So it should be here, just called ST-Link GDP. And then you can click finish. And we are done with all these pre-steps. And the last thing to do is to actually create the kit. So we go back into the kit section here, click on the kit tab, and then we add here a new kit. Let's call it STM32F769i. I do not need to set anything here. In the device type, we need to say it's a bare metal kind of device. The device is already selected. It's the board I just configured. This we can leave with nothing in the sysroot, nothing in emulator skin. The compiler, you can actually leave it to no compiler, simply because CMake will actually take care of finding the compiler. So no need to set anything here. However, we do need to set some environment variable here. So you just click on change here, and then you have just a text field. I will myself just copy paste the necessary variables. And these are the 3 variables you need to set. This is documented, by the way, so no need to remember what's here. The first one is to set the location of the ARM toolchain. The second one is to set the location of the Qt for MCU package location. And the last variable is to define the location of the STM F7 SDK. So once you have set all these 3 environment variables to your own locations, just click OK. And then on to the next field. The next one is debugger. Let's just select the debugger we have created, the ARM GDB. Qt version, this doesn't matter at this point. You just leave it to none. Nothing to set here as well. For CMake, just select the system CMake, the one you have actually installed yourself. And finally, the last thing to configure is the CMake configuration. Just click on change. You can delete everything that's in there, remove everything, and instead you need to define just only one variable, which is this one. So it's the CMake toolchain file. And you need to pass a configuration file which is included inside the Qt for MCU package. So you see this is the path to the MCU package, and inside you have a CMake directory, and you have one such CMake file for each board we support. So if you want to deploy to the F769, you set this. If you want to deploy to the other SD board, you would replace the name with the one you want to deploy to. Then just click OK. And we're done with the kit. So now we can actually start creating our project. So let's just go ahead and do that. You can click on File here, a new project. As I said earlier, there is not a full integration yet, so the way to create it right now will actually need to click on